Hello and welcome to yet another Math with Taebyn. My name is Taebyn. I'm a pup, bark, and today I would like to just do some fun math. I've done a lot of educational math, and so this will be educational too, but I think fun and interesting. You don't really need to understand any previous math or have a big background, because I want to talk about levels of infinity, which has to do with something called countability and uncountability. So let's just start off with kind of a silly, easy example. You can have a finite number of things or theoretically the infinite number of things. So for example, 5 apples is a finite number of apples. The set of natural numbers, so this is the set of natural numbers. But it's easier to write n like that, so that's what I'll do, but I'll say it's the natural numbers. This is infinite, right? It goes on forever. 0, 1, 2, 3, 4, 5, 6, 7, it just keeps going. So how many are there? Well, it is infinitely many, but we talk more generally, when we start talking about infinity, we talk about this notion of cardinality. Cardinality is just the size of the set you're talking about. It's not an official definition, so I'll put it in quotes, but definition, cardinality equals the size. And again, I'll put it in quote because you've got to talk about what does it mean by size. But I think we all have an intuition about what we mean by size. How big is it? So the natural numbers has a certain size. You can't use the number 6 or 7 or something to say that's how many things there are. So we have a new symbol for the natural numbers. The cardinality is something called aleph naught. Okay, so there's aleph naught. Where not, by naught, I mean 0. So that's what we call the cardinality of the set of natural numbers. Kind of a natural question in a way is, well, is there a bigger, in some sense, amount of infinity? So we can ask, what about the real numbers? What about the set of real numbers? And that notation for real numbers, I'll do this double R thingy. So remember, what's a real number? It's like 2, 5.67, the number pi, square root of 3, so on and so forth. And all the fractions and everything. These are all real numbers. Well, if you look, for example, let's think about this. If you look in the unit interval, so here's 0. If you think of a number line, 0 up to 1, you've got numbers like 1/2, 3/4. You've got all these other numbers in here, but you've got all the irrational numbers. It's the numbers that are not fractions. Like there's a ton of them. So just thinking about it, it makes sense that there would be more real numbers than natural numbers, right? Because even between 0 and 1, you've got all these infinitely many. There's like infinitely many numbers in here. So this is more real numbers than natural numbers. And in fact, the cardinality of this is bigger than this aleph naught. It is cardinality is aleph 1. Okay, so the amount of natural numbers is what we call countable. You can count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The amount of real numbers is what we call uncountable. You can't count them. There's just too many. Countable. But then here, this is uncountable. And well, what about the fractions? All the fractions are somewhere in between, right? Because it seems like there's somehow more fractions than natural numbers, but not as many as real numbers. Well, it turns out that by something called counter-diagonalization, it can be proved that the amount of fractions is the same as the amount of natural numbers. So the amount of fractions is actually countable, as is all the fractions. That is all the rational numbers. I'll just say fractions because we're more used to that. Okay, well, is that it? Like, is there any more? It turns out there is more. Let me just talk about this a little bit for a second. Well, a few seconds. I'm going to erase this. We've got countable and uncountable. So we have Aleph naught and Aleph 1. So here's, you've got the natural numbers. You've got the real numbers. Now, think of just any old set of real numbers. So say 3 pi square root of 2 negative 6.19. I don't know. There is a set of real numbers. Now think of another set of real numbers. It doesn't matter how big it is. 1.6, 1.72, 3, 10 million, whatever. What about the set 1, 1.1, 1.11, 1.111, and so on forever. So this keeps going on. So this just keeps going on forever. That's a set. That's a set of infinitely many numbers. Now keep doing this and think about all these possible subsets of real numbers, both finite and infinite. Take all of those. How many of all those sets are there? There's more than the real numbers, and there's so many more that we now have Aleph 2. The set of all subsets of natural numbers is Aleph 2, also called the power set, the real numbers. It's proven that there are infinitely many of these Alephs. There are infinitely many levels of infinity, and that is mind-blowing and so cool and fun to look into. So if you found all this exciting and wonderful, check out uncountability, countability, and levels of infinity. It's very cool, very interesting. Set 3, it all has to do with set 3, which also has very cool logic things that go on there too. So wow, what a journey we've had. That was so much fun. I hope you learned from it. I hope you had a good time. So with that, I'll just bid you adieu and say see you next time on Math with Taebyn. Bark, bark.